Year 6. I am hoping this will work. I'm trying something new again this week. This is because what we're doing in school is not going to quite match up with what you're doing at home. So in school this week, we are not doing an anchor task. We are not doing guided. We are not doing intelligent practice. And we're not doing dive deeper. All of our maths is going to be linked to our project work. But the problem then comes is that what we're going to be doing is measuring each other, and we are going to be calculating things based on that, and we're going to be doing some PE activities outside and measuring things based on those things and putting those things into graphs and things, which you can't do when you're at home, if that makes sense. So essentially what I've got for you is from the White Rose maths that we follow to do with line graphs and pie charts, but it's not with you having to measure anything in case you haven't got anything that you can measure with at home. So I'm just going to talk you through the questions basically, because without the anchor task and the guided, it's going to be a bit tricky to teach you. So the first graph is a line graph here, and line graphs we often use to show changes over time. So things like temperature are perfect on line graphs. So the first question is the temperature in Birmingham on one day. So we've got the time going along the bottom, and we've got the temperature going up the top here. So it says what was the temperature at 1 p.m. So essentially, to do the first question, we find 1 p.m. on our bar graph, on our line graph, which is here, and we follow the line up, okay, and we get to this little mark here. If we go across, you should be able to read what the temperature is there and pop it into your answer. So then the next part of the question says, what was the difference in temperature between 11 a.m. and 1 p.m.? I'm hoping this is going to, oh, I don't think it's going to work on here. You going to work? I was really hoping that that would be able to write on there. Never mind. What was the difference in temperature between 11 a.m. and 1 p.m.? So we look at 11 a.m. and we can go across to find the temperature at 11 a.m. and 1 p.m. you already know. So it just wants the difference between these two temperatures. C says, between which times was the temperature increasing? So look at where the temperature keeps going up, okay? So we've got this flat line here. So between 9 and 11, the temperature stays the same. And then we've got it going up here. Then it stays the same. And then look what happens. It starts to drop down again, look, after 5 p.m. So see if you can work out when the temperature starts, between which times the temperature is increasing. How often was the temperature recorded? Well, how many blue crosses have you got? Or black and white crosses if you've got it printed out on paper, I suppose. All right, then question 2 up here. Aisha goes for a walk. The graph shows the height above sea level during her walk. Okay, so we talk about sea level when we're measuring well, how do I put that? When you're measuring like the height of mountains and things like that, you talk about the height above the level of the sea. Okay, so we've got time along the bottom again and height going up the side here in meters. So we've got 50 meters, 100 meters, etc. What was the height above sea level where Aisha was walking at 2 p.m.? So we find 2 p.m. We follow the line up. Now, if you've got this printed out, you could use a ruler to do that. And then we follow the line across. Now, here we're in between two measurements. So to work out what this is, you need to work out the difference here. So the difference between 150 and 200 is 50. So if you can half 50, you'll know what this little gap is worth, and you'll need to add it on to this 150. Okay, you can do it down here as well. Look. So if this is 0 and this is 50, can you work out what this is And then you could always mark them all on look as you go up. That makes your life a bit easier. At what time in Aisha's walk was she standing 200 meters above sea level? So this time you're going the other way. Find your 200 meters, follow it across, and follow it down. I'm not going to do the whole lot for you. Part of the walk was along a beach. Between which times did Aisha walk along a beach? Think about what you know about a beach, and think about what you know about where the sea is, and see if you can put some common sense together there. It does say talk to a partner. Just send us in your answer, or talk to someone at home. That's fine. Oh, I've gone a bit too far there. Did the walk start and finish in the same place? Explain how you know. So the walk started here when she was 50 meters above sea level, and it ended here. So could that be in the same place? Have a little think about that. Right, on to the next page. So we've got another line graph here, just with two different things recorded on it. So I will try and print this out for you in colour, assuming that I can remember that I've said that. So we've got car 1 is blue and car 2 is the red line. We've got the value of the cars in pounds here and the year along the bottom here. So in which year was the recorded value of the cars the same? So can you spot a place where car 1 and car 2 are at the same point in terms of their value? So have a look at where your crosses fall, and then you're going to need to find the year along the bottom. In which 2 years was the difference in the recorded values of the cars the same? Isn't that the same question? Oh no. In which 2 years was the difference in the recorded values of the two cars the same? You're going to have to work out then the difference between the values here to try and work out when the difference was the same. There's a bit of working out to do there. Which car's value decreased the most between 1996 and 2020? So find your 1996 values for each car. Find your 2020 values for each car and see which one decreased the most. I'm wondering if you could do that just looking at the bar chart, at the line graph really. So here's car 1 and it goes down to here, and car 2 starts here and goes down to there. So I reckon you could probably do that without any actual calculations there. I'm just going to check how long this video is, so I'm not going too much over time. We're okay. So for approximately how many years was the value of car 2 greater than the value of car 1? So you want the value of car 2, the red one, being higher than the value of car 2, the blue one. So where is the red line higher than the blue line? Then what have we got? The value of car 2 halved between 1996 and 2012. Do you agree with Jack? So find car 2. What are we on? The red line. Find what it was in 1996. Find what it was in 2012. And are those two numbers half of each other? Is this, I'm not going to tell you what that is, half of that? All right, then. Number 4. Got another line graph. What could be happening on this graph? Write a story to match it. Could I suggest that this is time and this is something else? Can you work? It could be anything that you want really. So what could this graph be showing? I would make this time. It could be years, it could be minutes, it could be seconds, it could be hours, but I would do something to do with time. So it says, what would the x-axis be labeled? This is the x-axis going across. And what would the y-axis be labeled? So that is entirely up to you. Right, 2 questions that you can ask your partner. You don't have a partner, but you can ask us. Right, that is Monday's task. You should have plenty of time to do that. It shouldn't take you the full hour. Maybe 20 minutes, maybe half an hour. Something like that. So do make sure that you're doing the snappy maths work and that you're going on Rockstars as well, since we've got a bit of a different week this week. Okay. Right. I will record you another video for Tuesday's worksheet. Speak to you soon.